We're going to talk about, we just cover probability distribution. So we are going to talk about now binomial probability distribution. So binomial will belong to two category binomial. So the focus will be the binomial probability distribution and the, how do we find the probabilities, binomial probabilities. So there are also easy method to find the mean standard deviation of the binomial distribution. And we'll also talk about significantly low number or significantly high number of successes. So there are some four requirement for for a binomial probability distribution. So the procedure, a binomial probability distribution results from a procedure that meets these four requirements. The procedure has a fixed number of trials, right? So when it's a fixed number, it's 3 trial or 5 trial and so on. Okay. The trial must be independent, meaning that the outcome of any individual trial does not affect the probability in the other trial. So the events they're independent. Number 3, each trial must have all outcomes classified into exactly 2 categories. So we call them successes and failure. So those are the 2 categories. So that's why we call it binomial, right? Probability distribution, successes and failure. So this does not mean real good or bad. Failure does not mean bad. Just the way to differentiate them, right? Either one can be success, either one can be failure. Now the fourth one, the probability of success remain the same in all trials, so it stay constant. The number probability, notational probability distribution, binomial probability distribution. So S would stand for success and F would stand for failure. So when you say P of S, that means the probability of success. P of S is equal to P. So lowercase p will be the probability of success. So we say P of S. P of F will be the probability of failure. So we use lowercase q for that. So, and another way could be if you just want to use P, but this time that would be 1 minus P. So it's like complement. They're almost like complementary even. So P of S is equal to P, and P of F will be 1 minus P or equal to Q, right? So it's better to get used to Q also because there are in the formula we are going to use Q on it, not just P. Okay. N will be the fixed number of trials. Right? So X is specific number of successes in an N trial. So N can be any whole number between 0 and N. X can be between 0 and N. Specific number of trials. So X can be 5 or 6 as long as between 0 and N. Probability of success in one of the N trials, P. Q, probability of failure in one of the N trials. P of X, probability of getting exactly X success among N trials. So like, what is the chance of getting exactly 5 head among 6 tosses or 7 tosses? So X will represent that value, represent the number of tosses. Okay, so this use just doesn't mean it's bad or good. The number trial 5 is fixed. It says, suppose that we want to find the probability that exactly 3 of 5 randomly selected adults. So the total number of adults is 5, but you are selecting 3 of them. So which is one of the first requirements. Second requirement, the 5 trials are independent, right? Right? The probability of any adult knowing today is not affected by results from other selected adults. So if one adult knows today, it doesn't mean the other, because of that, the other one knows. They are independent, right? Each of the 5 trials has 2 categories. So there are 2 categories. So either the person knows or the person does not know. So those are the 2 categories. You can see here there is no bad or good here, right? Knowing today or doesn't know today doesn't mean it's bad or good. Number 4, for each randomly selected adult, there is a 0.85 probability that this person knows what today is, and that probability remains the same, right? Stays the same, it doesn't change for each of the 5 selected people. Now, part B, having concluded that the given procedure does result in a binomial distribution, we now proceed to identify the value n, x, p, and q, right? Number 1, with 5 randomly selected adults, we have n equals 5. Number two, we want the probability of exactly 3, or who know what tutor is. So x is 3, right? Exactly 3. So x is 3. The probability of 6 getting a person who knows what tutor is p of equals 0.85. So we assume know what tutor is, probably 6's, and failure will be q will be. So how do we find q? We know q is 1 minus p, so that will be 1 minus 0.85, which will give us 0.15. So it's probability of failure not getting someone who knows what tutor is 0.15. Again, 1 minus 0.85, you get 0. Again, it is very important to be sure that x and p both refer to the same concept of sixes. Okay, p is easy to find q. You just do 1 minus p. Okay, so this you can see here we have n x p, and we calculate. So you see how p of 3 is factorial over 5 minus 3 because our n is 5, and we compute it. So you can compute slowly and you get the result, but you have to use the 3 significant digit rule. This are 3 significant digit here. The probability of getting exactly 3 adults who know to the amount 5 randomly selected adults is 0.138. So that's very low. So we can also use technology to find it, but I don't want you to waste your time for that. But if you want to learn how to use technology, you can make your own research. If not, you can use TI-84 plus, which is you can go to mathbeats.com to how to use TI-84 to do these things. Mathbeats.com. Okay, so this is another example. We previously noted that between 1974 and 2011, there were 460 NFL football games decided in overtime, and 252 of them were won by the team that won the overtime coin toss. Is the result of 252 win in the 456 game equivalent to random chance, or is 252 win significantly high? We can answer that question by finding the probability of 250 win or more in 460 games, assuming that win and loss are equally likely. You have to determine what is n, what is p, what is q, and now you can use a calculator. So we use the technology here to find. But if you don't know how to use the technology, just use the formula we just went over. P of x is equal to n factorial over n minus x factorial times x factorial times p to the x times q to the n minus x. You can to determine your probability, right? So you have to use the technology. Okay, so it says based on the Harris poll, 60% of adults believe in the devil. Assuming that we randomly select 5 adults, use table A1 to find the following. The probability that exactly 3 or 5 adults believe in the devil. The probability that the number of adults who believe in the devil is at least 2. So this table you can find at the back of your book, right? You should be able to find it there, or I mean it's given here. So this is given to you, and this is just an example, by the way. So for the most part, if I'm giving you problem about probability distribution, I'll give you a table to use, okay? Or if the formula you need to calculate using the formula, so you already have your note, you can use the formula. So for the most part, the table will be given. You can use that to find the values that you need. But if the table is given, that means you don't need a formula, right? Because if I'm looking for P of exactly 2, so that'll be 0.01, right? P of exactly 3 is 0 plus. So that means it's really small number, 10 to 0. That's why it is 0 plus. And P of at least, so we want to, the phrase at least 2 sixes, it means that the number of sixes is 2 or 3 or more or 4 or 5, right? So at least 2. So that means you have to start from 2 and higher. So P of 2 or 3 or 4 or 5. So you keep adding. Remember this additional rule probabilities. P of 2 plus P of 3 plus P of 4 plus P of 5, and you get 0.913. So mean and n time p. This formula you can remember. Don't memorize it. Just read it and practice. Variance is n time p times q, right? So the only difference between variance and the mean is just the q, right? And the standard deviation is the square root of the variance. So you take the square root of that. Significantly low value, me minus 2 me. Significantly high value, me plus 2 me. So this is the range rule of thumb. We talked about that earlier, right? So using parameters to determine significance. Uh, so this is about the same game as previous example involved n equal 460 over time win in NFL football game. We get p equals 0.5, q equals 0.50, and by assuming that winning the overtime point toss does not provide an advantage. So both teams have the same 0.50 chance of winning the game in overtime. Find the mean and standard deviation of the number of wins in a group of 460 games. So we just gonna use a formula here, right? N time P, N time PQ, square root of NPQ, right? The mean, the standard deviation, and the variance. Use the range rule of thumb to find the value separating the number of wins that are significantly low or significantly high. Is the result of 250 overtime win on 5 and 460 games significantly high? So we have the everything here. All we need to do is to plug it in, and it's 460 p equals 050, q equals 050, and the formula is mu equals np, so n times p. 460 times 0.5 is 230 games. So this 0.0 just by respecting the rounding rule. Now the standard deviation is square root of npq, which is 10.7 games, right? For random group of 460 overtime game, the mean number of win is 230. So the mean number win game is 230, and the standard deviation 10.7 games. The values separating number of win that are significantly low or significantly high are the values that are two standard deviation away, right? For the mean from the mean. Mean equals 230 games and standard deviation 10.7 game, we get here. This is the range here. If any game that's not within this range is significantly high or low, depends on what side it is on. Significantly low number of wins are 208.6 game or fewer or lower. Significantly high number of game win are 251.4 games or greater values. And value not significantly are between 2.86 games. So there is no such thing as 2.86 games, but we can run that. And 2.51.4 games. So the result of 252 game is significantly high because you can see 252 is much more than is greater than 251.4, right? Because it's greater than the value of 251.4. Now this we can also use probability to determine whether when results are significantly high or low. So P of X or more, we mentioned this earlier, P of X or greater than X. X is random variable, number of successes among n trial is significantly high if the probability of X or more successes is 0.05. Right? So if high number of X, so this high number, it has to be X or more. Low number will be X or less. Okay, low number X or fewer, 0.0. Again, we have the formula here, right? P of X n factorial times n minus X minus n factorial times X factorial. The number of outcome with exactly X is among n trial. Probability of X is among n trial for any one particular order. Okay,